Hello everyone, I'm Ondřej Mirtes and I'm very happy to be here. And you are going to see a talk about PHPStan, and we are also going to be writing some code. So who already uses PHPStan? Yeah, almost everyone. That's good news, because this is not a beginner PHPStan talk. I already suppose that you are already using PHPStan and you want to enhance, you want to improve your experience by writing some custom checks against your code base specific to your project. And just to repeat a little bit what PHPStan is about, it looks for bugs in your code, and I created it because PHPStan is PHP isn't a compiled language; it's an interpreted language, and compiled languages have the advantage, and some might consider a disadvantage, that the compiler of a compiled language like Java or C# is not going to let you run your code if you have mistake in it, like access to an undefined variable or call to an undefined method and so on. But because PHP is interpreted, bugs and problems like that are happy to live years in your code undetected. And that's where PHPStan comes in, because it can analyze your whole code base at once and look for all these mistakes at once. So the output from it looks like this. It will point out when you have some obvious mistakes in your code like that. And some errors are really easy to do, and some are much harder to spot. So it also looks for problems that do not crash when PHP executes them, but it will point out code that is, for example, silently skipped because you only ask about condition. For example, in an if condition, when you ask about something that's always false, that code will always be silently skipped, but you probably didn't intend to write such code, because when you are writing an if condition, you sometimes want it to be true and sometimes false, right? And today I want to talk about custom rules. So the plan is to extend PHPStan with something that's specific to your code base, and in case of this talk and this conference, that is specific to Drupal. So the motivation for custom rules is that we want to make our code reviews easier. Who is doing code reviews? Yeah, a little bit less people. I hope that you don't rely just on PHPStan in your CI. So in code reviews, when the same problem comes up over and over again, it takes away your valuable time as humans from doing actual work, right? You have to point out the same mistakes that your colleagues do over and over again, but it's an opportunity to use automated tool like PHPStan to point out these problems. So it's already solved before the code reaches a human reviewer. And you can use custom rules to prevent bugs and production incidents, and you can use them to achieve consistency and quality. So it doesn't have to be only about bugs in your code. It can also be something similar to a coding standard, because you can write a custom rule for reasons like you want specific code to look a specific way, to do the same thing always the same way, even if the framework allows it to do multiple different ways. And every time you experience some repetition in your code review, or if you experience a bug in production, some kind of production incident, you should ask yourself if PHPStan could have figured out this problem just by looking at the code. And if the answer is yes, you should look into a way how to catch these problems next time with a custom rule. So when I was preparing for this talk, I looked through the feature request on the issue tracker of the PHPStan Drupal extension to find some ideas. And I really like I really liked this one because it allows me to show off what kind of unique information PHPStan has in order to help you catch this in an automated way in a custom rule. So the problem is that we are calling get storage on entity type manager interface in the constructor of some kind of block or form on controller. And the problem is that this operation is expensive, which means that it takes a long time to perform because the framework has to initialize some stuff and query some stuff in the background. But if the actual storage that we save into the storage property is not always used when the piece of code, when the plugin, the block, the control is executed, this means that we just wasted some computational time because we initialized something and we throw it away because it's not used every time. So this also demonstrates the power of custom rules because PHPStan cannot suppose that this is always a mistake, right? Because this is valid PHP. You can do this. It's not going to crash your application, but only in case of Drupal, it's going to make it a little bit slower, maybe sometimes in specific situations. So PHPStan itself cannot report this as a problem because this is valid PHP, but it's not valid PHP in the context of Drupal or in the context of your application when this is called inside a constructor. So this is the idea behind custom rules. It's valid PHP, but it's not. We prefer it to not be in our custom code base. And you probably will, once you start implementing custom rules, you will get ideas for even more and more, because it's a very addictive process. So in bigger developer teams, it can even be a full-time job, just managing PHPStan and writing custom rules, because improving developer experience really pays huge dividends when your team gets bigger and bigger. And if you imagine all the saved time and all the increased productivity thanks to that, and it's very, very rewarding. So now is the moment when we get more technical. So PHPStan does its job by using something called AST, Abstract Syntax Tree. Who has ever heard this term? Yeah, quite a lot of people. I'm quite surprised. And for the rest of you who haven't heard about it, it's a way to represent source code using objects. So let's take this expression. Let's say that we have this foo, and we have some kind of property fetch, and on the right side we have a static method call. So with AST, this is represented using an object structure. So we have the root expression at the top, the Boolean end, and on the left side we have the property fetch, and the property fetch node tells us on what object, on what node is the property fetched, and what's the name of the fetched property. And on the right side we have static call, and the static call tells us on what class name it's called, and what's the name of the called method. And there's a great library that enabled PHPStan to exist, and also a bunch of other tools to exist. And it's PHP Parser by Nikita Popov. And if you are not familiar with the PHP Parser and you want to write your first custom rule, you can probably check out the list of possible nodes that PHP Parser uses to represent the source code. And you can see the generic documentation that lives over at apiref.phpstan.org. That you can see that in namespaces there is the PHPStan namespace that I list all PHPStan classes and interfaces you can use. But because essentially PHP Parser is part of PHPStan's API surface, I also generated the documentation for PHP Parser, so you can see the list of nodes that PHP Parser uses to represent source code. So when you look at the class names, they feel a little bit familiar, right? Because they represent all the possible constructs, all the possible keywords that you can have in your source code. And when I will live code the rule in a few moments, I will show that you don't need to remember all of these before you can write your first custom rule, because I will show you a few tricks how to figure out what nodes am I interested in. So, our first custom rule. When you want to implement it, you have to implement this interface rule, and you need to implement two methods. So the first time is get node type, and the second method is process node. So who has already written some custom rule for PHPStan? Okay, 3 people. And who has ever written a custom sniff for PHP CodeSniffer? So you can see that the get node type method is a little bit similar to how you write sniffs for PHP CodeSniffer, because I actually used to write custom PHP CodeSniffer sniffs before I created PHPStan more than 10 years ago. So I kind of got inspired by the way how PHP CodeSniffer implements the custom sniffs. So this is how the interface looks like. Get node type, you are supposed to return the class name of the node, of the AST node that you want to hook your rule onto. And the second method will be called every time this specific node type is found in the source code as the analyzer traverses throughout the source code and looks for these nodes. All right, so now's the time that I will implement the custom get storage rule. I've already prepared a project, Drupal project, and I took the liberty to already install PHPStan. So we have PHPStan, we have extension installer, and we also have the PHPStan Drupal extension from Matt Glaman, which is useful because it will make PHPStan understand your Drupal codebase better, and it will remove false positives. And it also ships with some useful custom rules already. And here's our controller, and this is the kind of code that we want to detect. So we are in the constructor, we inject entity type manager interface, and we call get storage in the constructor. And this, in our real world code, this is the problem, because this might not always be used, but only when some condition passes. Okay, so this is our rule. One more thing that I had to configure is that I had to put the path to where the directory where the custom rules will be at. I had to edit to autoload def so that PHPStan can see the class, and I decided to put it under our custom module under the build directory. So web modules custom Drupal build, and thanks to this line, Composer is going to see this class, and PHPStan will be able to load it. And I also configured PHPStan, and I registered the custom rule like this. But the rule doesn't do anything useful yet. So in get node type, when you are just starting out writing custom rules, you have no idea what kind of node are you interested in. So a good idea is to hook your rule onto all nodes and see, try to run it on a file and see what kind of nodes are used when parsing the source file. So, and then you can debug it. You can debug it with xdebug, or you can debug it the old-fashioned way using var_dump calls. So now I'm going to run it. Can everyone see it clearly? Is the font big enough? Okay, just okay. I will increase the font size a little bit. Okay, I hope it's enough. So now we analyzed a single file. We analyzed the hello world controller. There is the piece of code that we want to flag with our custom rule. And when you see the types of nodes that PHPStan encounters in the file, you can kind of follow the structure of the file, right? So you can see that we have declare item, integer, which means that this number. We have a namespace, we have 3 uses, then we have a class, and so on. You can also notice that some nodes are not from PHP parser, they are from the PHPStan namespace, and these are so-called virtual nodes, and I will be talking about them a little bit later. I will address what they are for. And if we follow the structure of the file, we can see that here we are in a class method, which means that this is a declaration of the constructor. This is the parameter. This is the name of the type hint of the parameter expression. This is the entire line 18 is the expression. We have an assign, and on the left side we have property fetch, and on the right side we have a method call. So this node is what we are probably interested in. Everybody follows? Okay, great. So this is what we are probably interested in. So we will register our rule for the method call node. And now if we run it again, it was called twice. And that's because it's called for this method call and for this method call. So it's there are no more method calls in this file. There are method declarations and there are other things, but there are only 2 method calls, as we can see. All right, so now in order for the IDE to autocomplete things here, because right now we don't get anything useful, anything method call specific here. We need to help ourselves with generics a little bit. Who is familiar with generics? Okay, not everyone. It doesn't matter for the purpose of this talk. You just need to know that you need to type this here. And this helps not only PHPStan but also PHPStorm, because now it knows that it can autocomplete specific properties that are on the method call. So what does method call consist of? It consists of var, what is the method called on, it consists of a name, and it consists of arguments. And you can see that var can be an expression, and name can be an identifier, basically a name or an expression, and this is an array of arguments. And why is this either an identifier or an expression? It's because the PHP parser has to account for all the possible PHP code that one can write. So this piece of code is also valid PHP code. So you can have something like method name this. So this means that this is going to be an expression. But in our case, we are only interested in usual method calls that look like this, which means that if the method name is not an identifier, we can return array. And now we can check that if the name is not get storage, we can also return array. I'm doing this on purpose because method names in PHP are not case sensitive, which means that you can call the method with a wrong case and it's still going to work. PHP is pretty random about this. So, for example, properties are case insensitive. Properties are case sensitive, but methods are case insensitive. And constants are also case insensitive. Sorry, the opposite, case sensitive. All right, but I'm sure that I need to do this for methods, so that's one thing. And now we can report the problem, and then maybe we can point out a few problems that we have with our current logic. So in the past, it was possible to just return plain strings here, but it's no longer possible since PHPStan 2.0 for about a year, because now you need to return an object. And you usually go about instantiating this object by starting with a rule error builder. So you can do rule error builder get message, and you can say get storage is called in constructor. And in order to go from rule error builder to rule error, you need to call build. So now it should report an error. Line 18, get storage is called in constructor. All right, perfect. So now we can point out everything that's still wrong with our rule, right? So we actually didn't check that we are in the constructor. So if we do the same thing here, it's now going to report 2 errors, right? But this is valid. And in order to fix this, I need to teach you one more concept. And the concept is scope. So it's the second parameter of the process node method. And you can use it to query about anything about what you are interested in your code. So scope updates as it goes through the source code, so it knows the type of every variable that has been assigned. It knows where you are currently, what's the name of the file, what's the name of the namespace, if you are in the class, if you are in a method, if you are in a function, it knows everything. So this is not the whole list of methods. The list is much longer, but you can get the idea of what's going on here. Scope basically knows everything about the current place in the code where the rule is executed. And the most interesting method here is getType, which can be used to get types of expressions. So in the AST, language constructs are represented either as statements or as expressions. And I want to give you a little quiz. So first I'm going to give you a few hints. So expression can resolve to a type. You can always get the type of an expression. And expression can be put into another expression. And statements are usually some branching logic, or for example, loops are statements. And yeah, you can probably figure out which of these are expressions and which are statements. So let's try it out. So who thinks that variable is a statement? Who takes an expression? Perfect. Who thinks that return is a statement? And who thinks it's an expression? Yeah. Return is a statement. Yeah, variable was expression. You were right about it. And return is a statement which can contain an expression, right? We can return something, or we can just do return semicolon, which means in which case the expression is going to be now. Switch statement or expression. Yeah, switch is a statement. It's branching logic. You cannot get a type of a switch statement. Yeah, it doesn't make sense. What about assign statement? Expression? Yes, it's expression. You can actually do something equals something and use it as argument of a function call, right? So it's an expression. What about instance of statement? Expression? Yes, it's an expression. The type of instance of is a Boolean. You can do something instead of something, and you can use it directly as a function call argument. All right, so this gives you the idea of what get type, scope get type is for, and what you are going to get back from scope is the type interface. Okay? And again, type interface is going to answer all your questions about the returned type. So it can tell you whether this type accepts a different type, if this type is equal to a different type. You can ask to get a string representation of the type, which is the describe method, and you can ask everything that you want about type. So now we can use scope in our get storage rule. So the first bug that I want to get rid of is the line 26, right? Because it's wrong. So here we already know that we are dealing with get storage, but let's say that we are in a class, and if let's get the current function or method, and if it's not null, and if it's not a constructor, we are not going to report any errors. So right now we are outside of we can be sure that we are inside the constructor below this if condition. So now on the line 18 is reported in this place. There is one more problem with this logic. So anyone wants to guess what is the problem? Just shout. Yeah, just shout at me.
Well, it's strange. Like if it's not null, then what happens then?
Sorry, what?
Like if it's null, then it will still be wrong. You can still pick it up. Although it cannot really happen, right? If you have a class, it has to be a method.
Yeah, probably. But you can be, for example, you can be in some kind of property hook, or you can be in some kind of default property value on some weird thing like that. So you need to check this. The big problem that we have here is, sorry, you want to guess?
You should check the anti-type manager interface.
Exactly, yeah. We might have some different method that's called the same, and it might be a completely irrelevant thing that's actually okay to call in a constructor. So if some different class has also get storage method, then we don't want to flag it. We just want to limit our rule to the get storage from entity type management interface. So we can get the type on which the method was called. Scope get type, node var, and if the type does not have the method, where can I get the name? And it's it doesn't return just a boolean. Oh. It doesn't return just the boolean. It returns trinary logic, which means it has three states: either a yes or no or maybe. But that's a too complicated topic to just get into now, so you have to trust me. So if the method does not exist on the type, we can return early, and now we can get the method. Get method. It wants scope as a second parameter for some not interesting reasons. And now we can check things on method. So now we are actually in the reflection layer. Who knows what reflection is? PHP reflection. Yeah, it's basically asking about metadata about our code. So now we are using reflection to query more interesting things. So we can check what's the declaring class of the existing method that we just called. And if the name is not entity type manager interface, we are going to return early. So now we also solved this problem thanks to scope. So now I think that the rule is good enough.
What is a subclass? Yeah, please start.
Yeah, we are calling it on this, but you can also do subclass. So I think there's also shortcut that will take care of this. So you can do this, and the implementation actually looks at the name or if it's a subclass. So yeah, it's also going to. Why is there? Oh, because I need to do this. Okay, nice. And if we not only run the rule on a single file, but on our whole custom module, it will check everything, and it's also a good idea to check the rule itself with PHPStan, because PHPStan is going to check if the rule is written in an okay way, and it might be able to find mistakes in the rule. So it tells us that the error is missing an identifier, which identifiers are now required, and we can give it an identifier thanks to the rule error builder. Identifier Drupal get storage. All right, and the identifier can be used to ignore the errors. So we can do PHP ignore, and now no errors. If you don't want your developers to be able to ignore errors, you can say it's not ignorable. Yeah, so now PHPStan is going to complain even more than before. Yeah. So I have some more inspiration for you, some more ideas for custom rules. So one of them is that you should maybe disallow doing creating new objects for classes that are already registered in your DI container, because you should be injecting them into a constructor, and you should not be creating them manually again in your code. You can use custom rules to make your code a little bit more readable. So, for example, you can use it to enforce named arguments for attributes, because then they will become like more self-explaining. You can also use it for security reasons. So if you want to prevent SQL injection in your SQL queries, so that you can detect string concatenation, right? You should use placeholders instead, so you can write a custom rule for that. I promised you explanation of virtual nodes before. So if you are only looking for things with your custom rules that are present in the code, then it's really straightforward, right? You hook your rule onto an existing node, and when PHPStan finds the node, it's going to call your rule. But what if we want to write a custom rule for something that's not in the code, right? I had to solve the problem in PHPStan when, for example, function is supposed to return something, but the return is missing, right? Then I don't have real nodes to hook onto, so that's why from time to time I need virtual nodes to solve specific use cases for things that are not in the code or are not that easy to figure out from code. So, for example, if you want to enforce declare strict types at the top of each file, you want to report an error when it's missing, right? When there is no declare strict types at the top of the file. So without virtual nodes, you wouldn't be able to do this. But with virtual nodes, there's a file node that's called at start of each file, and you can inspect what the file starts with. So you can report an error if the first statement is not declare strict types node. So that's what virtual nodes are for. What's very new and what's quite experimental in PHPStan is that you can write auto-fixable rules. So you can call on rule error builder, you can call fix node, and anyone has a guess what is this going to do? Okay, just shout. Yeah. So this is part of source code of a rule that enforces final classes. And if I do this, PHPStan is going to know that it's going to be able to fix the code on my behalf. So that's quite new and experimental, and it's not promoted anywhere yet, but it's already possible to do this today in a stable version. All right, a few more topics. Restricted usage extensions. Any chance that anyone already used these? Okay, no one? That's okay. So the idea is that you don't always have to implement a full-fledged rule. I recently started publishing like simplified interfaces that look like this. And the idea is that if you want to prevent a call to something from a specific place, you don't have to write a full-fledged rule. You can just implement this a little bit simpler interface that you will just return, is this allowed or not? Am I allowed to call this method from this place? I actually could have used this to also implement our logic that I just showed you, but I wanted to show you an idea how to write any kind of rule, not just this specific use case. And the idea behind this is that it makes it really easy to write, for example, architectural rules. So if you want to enforce that some layer from your application is not supposed to be called from this layer, if you want to, for example, enforce a flow of dependencies in your code, you can implement a few restricted usage extensions, and it's going to make your life much easier. And I already use them internally, so I refactored PHPStan deprecation rules, which are also used by PHPStan Drupal to use these extensions, and it actually found a lot of cases that weren't previously covered by the existing rules. You don't have to use it just for methods, but you can use it generally for class names. And the good thing is that you just implement a single interface, and then PHPStan derives from which places this extension is going to be called. So in case of class names can be mentioned in a lot of places in your code, and I counted them, and it's 27. So if you want to disallow some class name to be mentioned in some specific place in your code, you don't have to write 27 rules. You can just implement a single interface, and PHPStan is going to take care of that. Collectors. So rules only check a single place in the code. They are very powerful. You can ask PHPStan, because PHPStan knows everything about your code base, but you are still checking a single place in your code with a custom rule. For example, if you want to write a rule that would report if some place in your code, some function or method is not called at all, if it's dead code, you can't just do it from a custom rule, because custom rule doesn't have all the context. It doesn't see. It can see the declaration of the method, but it doesn't see like all the places where a method is called from. But with collectors, it becomes much easier, because you can write multiple collectors, and then you can evaluate them at the end with all the collected data from your whole code base. So then it's much easier to write rules about unused code, because you will write one collector for method declarations, you will write a different collector for method calls, and in the end you will see both of these data sets in the single place, and you will be able to compare them, and then you will report all method declarations that aren't actually called anywhere in your code, and that's the dead code that you want to report as a problem. Of course, you can test rules with PHP unit. We don't have time to get into this today, but you can check the documentation. It's pretty straightforward. You just write down the expectations you have when analyzing a single file. And you should familiarize yourself with all the core concepts. I touched all of them today, but you can learn about them in depth in the documentation. So the core concepts that you need to use to write custom rules are abstract syntax tree, scope, type system, reflection, and dependency injection and configuration. Dependency injection is just a fancy name for asking things in the constructor, right? So that's what it is. And it's all described in the documentation. So we are nearly at the end of our talk, and we just spent half an hour learning about how to write custom rules. I wouldn't say it's the hardest thing in the world, but there's still some learning curve to it. But I have good news for you. You can just ask ChatGPT, and it will do it for you. So I tried to ask it to write the exact same rule that I was showing you how to implement today, and it worked surprisingly well. So first I told it what I wanted to do, to kind of let it warm up a little bit, to have a little bit more context, and then I asked for the specific thing that I want to implement. And yeah, it made a few different choices to how to ask about what kind of method are we in, but basically this code works fine. It will even tell you how you can register it, and it understood what I'm trying to detect. So you can use it to get started, and it will not always get it right on the first try, but you will be able to get pretty close. But still, it's very valuable to familiarize yourself with the concepts, and you should be able to write these rules yourselves. But of course, you can use ChatGPT to maybe be a little bit more productive or faster. All right, I still want to show you a few extensions made by other people. So, anyone is using that code detector? It's really awesome. It uses collectors and custom rules, and it's really world-class dead code detection. So the idea is that it will show you code that you can remove from your code base, which isn't used at all, and it's really smart. It's really clever. It can look at your routes. It understands what code is used by a framework, and you can also customize it so that if, for example, even if it doesn't understand Drupal today, you can implement some interfaces to make it understand how the framework uses the code, so that in the end you can have zero false positives, and it's very customizable, very configurable, and it's very smart, and it does very good job. PHPStan DBA from Markus Stab is able to look at your SQL queries, and it can figure out how the results returned by the database exactly look like. So without this extension, you will just get a mixed type, and PHPStan wouldn't be able to report any errors. But here it exactly knows that this query is going to result in an array with these keys. So PHPStan is able to use that, and it can tell you if you are accessing something that's actually not in the results. And it can also tell you when you have some pretty bad mistakes in your SQL queries. And the last one that I want to show you today is PHPStan to-do by, which looks at to-do comments in your code that contains dates, and if it's October 14th, that this is going to be marked as an error in your CI when you run PHPStan, which is really useful. So you will not find it 5 years later and see that something should have been done 5 years ago, but PHPStan is going to tell you about it. And there are even more. You can look at the list of extensions in the documentation, extension library, and also you can search packages for these extensions. If you search for PHPStan, and on the right, when you click on PHPStan extension, you can browse many extensions and many custom rules that people have already wrote. All right, if you try to write a custom rule later and you bump into some problems, you can open a discussion on GitHub, and maybe some other contributor will help you with your problems, and you will be able to finish your custom rule. All right, that's everything from me today. And if you are interested, there are stickers on the floor that you can pick up after my talk. Thank you very much. And please rate my talk using this code in the app. Thank you. So do you have any questions?
Directly with microphone?
Yeah, someone will come with the microphone.
It seems that some of these extensions, they don't say make rules to say this is wrong, this is good, but they make prediction about types, right? So which could be something else, right? So they take the SQL and then they tell the engine like what are the types of the result. Because I'm interested in something for callable types where I want to use attributes to declare the parameters of the callable and they put it on the parameter that contains the callable value and stuff like this. And so if we would write an extension that we wouldn't use this rule, that's something else, right?
Yeah, so custom rules are only one type of extension that you can have in PHPStan. And there are many more interfaces that you can implement for other reasons. So for example, there are dynamic return type extensions that, for example, if you want to tell PHPStan that this is going to return the same type that you put there, or for example, if you are calling a DI container and you are passing a service name, you want to tell PHPStan what's the type of the service so that you can use this information as the analysis continues. So there are many kinds of different extensions that you can implement. And I'm not sure about your problem. You can maybe describe it later in GitHub discussions and we will take a look. Thanks.
Sorry, this is less of a question, more a quick shout out. So, I'm Ed Bauman.
Hi.
Just so everybody knows, if you use Drupal check, upgrade status, or done any major version upgrades since Drupal 9, it is all powered by PHPStan. So it's great that you're here seeing this session, and I just hope you realize the impact this project has had in your day-to-day life. So, thank you.
Thank you. All right, anyone else?
Yeah.
Okay.
The custom code.
Sorry, Mike.
You showed the collectors for the Drupal action. Now, when you use Drupal or Symfony or some projects, and you can use YAML or XML files to define the usage through, for example, event dispatcher. So the question is, like, can you provide additional metadata for that collection? Like, okay, I don't use it in the code, but I'm using that implicitly through dependency injection.
Yeah, so I will show in the documentation how the collectors work. So the idea is that you have the collector, like it looks very similar to a row, right? So this is executed like when the analyzer encounters a trait, and you can have multiple collectors like this, and in the end, a special rule that hooks onto this node is going to be called, and here you can have any logic that looks at all the collected data. And also, besides like checking what the collectors collected, you can also read any file you want, and you can like consider it as another data point before you decide like what errors should be reported in the end. All right, anyone else? All right, so stickers on the floor. Thank you very much.